Hello and welcome to the Efaflex Sales Academy. Probably you know the situation from the everyday work as well. Doors in the warehouse, production or refrigerated test areas open and closes 100 times a day. Extreme temperature differences between outside and inside is one of the most important challenges in the freezer area. Exactly that's why Efaflex developed a high-speed spiral door TK-100. Our expert, Klaus Manlik from the Sales Academy, is explaining to you the background information and how it works.
Thank you, Rebecca. My name is Klaus Manlik of the Efaflex Sales Academy. Over the next few minutes, I will introduce you to the Efaflex deep freeze door, the SST TK-100, which you see behind me. Ms. Gris Hofstadter already mentioned the design of the door was a real challenge for two main reasons: physics and logistics. In the deep freeze areas, the physical laws, or to be more specific, thermodynamics, challenged us in three different ways. We needed to compensate for temperature differences, we needed to avoid icing, and finally, we needed to minimize energy loss. Let's take a look at the physical details. In deep freeze areas, we have to deal with temperature differences of between 35 to 40 degrees Celsius. The temperature differences result from the requirements of the operator of those doors. We usually find three different temperature areas: the deep freeze area itself with -30, the preparation area, and external temperature, which will be ambient. The temperature differences in connection with humidity lead to icing. Not only does this present an issue to the limitation of the functionality of the doors, but also increases the risks of incident or accident. Let's take a look at the following graphic to understand the background. What leads to this icing effect? Physical conditions like humidity and temperature will automatically cause certain reactions. The warmer area is, the more humidity it can contain. The humidity condenses on colder surfaces when the temperature is low enough, which leads to icing. The relative humidity, always shown as a percentage, says nothing about the real amount of water in the air. Here, we show you a table that visualizes how much water you really find in the air depending on the recent air temperature. As you can see, cold air is much drier than warm air. So what happens during the opening of the door? When the door is opened, we find two contrary air movements, which will balance the temperatures. Cold air streams out of the freezer at the lower half of the door, while warm air streams into the deep freeze area in the upper half of the door opening. When the warm air cools, it loses its moisture through condensation on the contact surfaces. In the lower half of the door, the outflow of cold air results in a cooling down of the surface of the door. This icing can result in heavily ice-packed equipment and also damage the functionality and compromise the safety of the door. The photographs here show some examples. So what did we learn from this? The better a door is closed and sealed in the opening, the lower the air leakage of the system. The lower the condensation, the lower the ice formation. So it's essential for a door in a freezer application to be as airtight as possible. To make sure this doesn't happen, Efaflex developed a highly insulated, extremely well-sealing high-speed door, the EFA-SST TK-100. Differences in temperature will automatically result in energy loss, which needs to be minimized to be energy efficient. Therefore, effective sealing and insulation measures must be taken. Let's have a look at the sample of the door panel and how this was realized. The insulated panels of the TK-100 are completely thermally separated and are 100mm thick for optimized insulation. The U value of the complete door is as low as 0.62. Here we see the intermediate seal. You'll find the same seal between all neighbouring door panels. This prevents an uncontrolled exchange of air. The seals are equipped with an extremely energy efficient heating system operated with a 48 volt, safe, low voltage system. The heating cables have a power consumption of approximately 20 watts per metre length. The unique detail with this door is the innovative sealing solution developed to seal the blade towards the wall. Efaflex designed a mechanism that enables the complete door blade to move horizontally into a perimeter seal. Towards the floor, the door is sealed with a heated safety edge profile. This system makes sure that all four sides of the door are equipped with heated seals. The rubber material is specially selected to stay flexible and doesn't harden. Only a flexible seal can fulfill its duty, optimizing the sealing. Cold rubber will harden and become rigid, and then it isn't flexible and it cannot form the seal anymore. To protect the perimeter seal from wear and to extend its lifetime, the complete door blade is being moved horizontally just after leaving the closed position for around an inch. We can now see this in the video. Because of the horizontal movement, the door can seal the deep freeze almost hermetically. All joints and edges around the EFA-SST TK-100 door are securely sealed and also heated. The air permeability of the door was tested and confirmed to achieve Class 4 according to DIN EN 13241-1. The requirements of the door systems in freezer environments present a number of logistics challenges, and there's three different aspects. We need to guarantee the logistics flow. Safety for the people and the equipment in the area must have top priority. And finally, automation plays an important part. In spite of the extensive technology, the TK-100 door opens at approximately 1.5 meters a second and closes at approximately half a meter a second. As the TK-100 was originally designed as an industrial door for a high-frequency operation, it's designed for up to 200,000 opening cycles per year, with a lifetime expectancy minimum of 10 years. A higher number of opening cycles does not cause a problem. It only calls for additional maintenance visits. And it's not uncommon to see spiral doors with over 5 million cycles on the counter. The TK-100 can be installed on either the cold or the warm side, but installation on the warm side is clearly preferred, as electronic components as well as icing cause less problems on the warm side. We obviously had to think about door safety too, to protect people from a moving door, but also to protect the door from being damaged. The TK-100 is equipped with a door line light grid, a TLG system and a safety edge as well. The TLG is a touch-free safety system which secures the door opening up to a height of 2.5 meters from finished floor level. Das die Torschließebene bis zu einer Höhe von 2,5 Metern überwacht. As soon as the TLG is activated, the door slows and stops, and then immediately returns to its open position. After clearing the TLG across the door opening, the door will automatically time out and begin to close. Of course, manual operation is also possible by operating the hand lever on the door frame. This enables the door to open quickly, for example during a power cut, to provide access. Although it should be noted, the door is not rated as an emergency exit. Here we see the controller for the TK-100, the most modern door controller on the market, the Efaflex Professional. This is a microprocessor control with integrated frequency converter. It permanently displays the status quo of the door and the number of operating cycles completed. Any incident with effect on the door is immediately shown on the display. The controller allows the use of all common operating sensors and safety systems, and all the communication with building management systems or external control. For example, a conveyor system can also be realized without issue. Even an intelligent door network can be created via Wi-Fi technology. EFA Smart Connect also enables a communication of the door controller with a smartphone or tablet and offers the possibility to exchange door data easily and simply. This helps to optimize service visits to make quicker and more efficient repairs. To summarize, the performance parameters and technical features make the TK-100 a perfect solution for deep freeze applications. Many of our clients could realize significant savings on energy usage and could also realize amortization within just a few short years of installation.
Thank you for joining us today at the Efaflex Sales Academy. I hope you will turn on again next time when it comes to background information and special requirements around high-speed doors. And don't forget, follow us on LinkedIn and Facebook.